project house is a kind of smart storage to hold your projects. It is located under its so-called root, a path in the file system to a folder named project house. This would be the root of a similar project house on a Windows PC. In the file system of your computer, this is the root of this project house. The project house with all its parts entirely exists under this root directory. You can also have 2 project houses on your machine, or more. Or the project house can exist somewhere on your local network or even somewhere in the cloud. The Caretaker is a program that creates and maintains these project houses. It is free and open source, and when installed, you have a Caretaker command available on your machine. But you will not use that a lot, because you can also start its graphical user interface, or GUI, and then you can do all your project management in your favorite web browser. Here, for example, is the simple homepage of this GUI. Its only content are some links pointing to online help. The headline at the top is the same for all pages of the GUI. The left button always brings you back to this GUI homepage. The middle always displays the root of the project house you are in, and the buttons on the right make up the simple GUI menu. This is the so-called archive. The archive is the overview or library of all existing projects in this given project house. Not all projects are active. Only active projects can be modified, and the so-called workshop is the place of all these active projects. A project in such a project house itself is defined as a unit containing 3 independent parts. The active project tree, holding the entire project content in a collection of files ordered in a custom folder hierarchy. This, of course, is a project in the narrower sense, as a current state of the product that is to be developed. A project description, holding some data and information about the project. And any number of backups, each backup being a saved snapshot of the file tree at some point in time. Actually, this definition of a project is that of an active project, because active means that the project tree does exist and the project can be modified. A non-active project does not have an active project tree. Activating it means that the file tree of the most recent backup is recovered and rebuilt in the workshop. In the browser, an example of a fairly small active project looks like this. There is a current file tree in the gray area, showing its content with colors reflecting the last modifications. There is a description which can always be edited at any time. And there is a list with any number of backups. In this case, there is just one. The distinction between 2 virtual rooms is a crucial design feature of a project house. The archive is hidden in the basement and stores all projects, active or not, in a very efficient and irredundant content-addressable storage system. The workshop is a place where the active projects are opened. The virtual workshop in the file system is just a name for the content under the project house root. When projects are activated, their file trees appear under this root, so that they can be modified like conventional projects. In a project house, all your projects and each history of every project are stored in a nice and clean fashion. The Caretaker in a project house is a new approach to digital project management. In order to understand this new solution, let us first describe the problem. What is digital project management and what is a challenge? Nowadays, talking 2017, computers come in all forms and sizes. Many of them, especially the smartphones and tablets, are entirely used as interfaces to internet or network services. But the classic use case of personal desktop computers was and is the production and processing of digital products. Things that exist as software, a text or book, scientific, artistic or commercial papers and documents, music file, animation, movies, drawings and construction files, websites, computer programs. Any of those digital products is essentially a file or many files with some optional order and structure through folders and subfolders. The production of such a digital product usually is a larger process, involving changes in different states through time. This process is usually called a project in a wider sense. A project is an investment of time and resources to achieve a certain goal. And a digital project is an enterprise that aims at products done with and kept in computers. And one paradox of digital project management is the fact that good, successful products prolong their own development. Many products start to die if they are not permanently updated. Many projects not only produce a product, but a whole history with different product versions. There is an established subject in economics called project management that tackles the challenge of costly developments in, say, construction or urban planning. We define the art and science of digital project management as a design and implementation of strategies to assist the development and bookkeeping of any number of digital projects. Digital project management is what productive people do on a daily basis in a more or less idiosyncratic fashion. Despite the diversity of computers and humans that use them, there's one common ground and home for all digital content producers: the file system. There are many operating systems, and each one has different file system formats. But for the user, they pretty much appear and behave the same, and it is easy to move files and entire file trees between different machines. The file system is a tree structure of folders, here orange, and files in green. And this is universal and powerful for good reasons. First, the whole is a fairly simple design and easily comprehensible. Second, it is flexible, a free and custom order with custom names. Third, it is general enough to cover not only my own projects, but also the machine itself. Devices and programs are also files and file trees. For all creative computer users, the file system is a real world and ecosystem for project development. This is good and will not change in any foreseeable future. And this is how we content producers are used to develop our projects, as branches, as new file trees. The standard strategy for each new project is this: create a new dedicated folder and put all the content in it. But by choosing the location and name for the folder, the potential trouble has been created as well. Suppose I am an author of travel guides and I call my new project Travel Guide for Suriname. This is the title. But when I create a new folder and give it a name, this name becomes the identifier for my project in the file system. Usually I choose this identifier so that it is close to the title. And since modern file systems usually allow spaces and other strange characters, I could name the folder Travel Guide for Suriname as well. But these kind of many word names are awkward to use, and programmers often merge them into one word, for example with underscores as connectors, or by so-called camel casing. Or I go for a more concise identifier and deviate from the title towards Suriname Guide, or just Suriname in case I already use a superfolder travel guides for all these kind of projects. Anyway, suppose during development I choose to change the title to Suriname on a budget in order to meet my potential readers. Or the content character has changed and the proper title now is Travel South America. It is no problem to change the title in the document I'm writing on, but it often causes a lot of trouble when the identifier and the folder name is changed. Open programs may crash and links get broken. The same happens when I rearrange the order of my projects and move the whole folder with its content to a new location. Things often break really bad. When I am productive, the number of projects will grow and it will be increasingly difficult to keep track of my productions. Again, each time I reorganize a whole, things are likely to break. And cleaning up always causes another potential hazard. If I remove old projects, I might really regret that. Not that I don't have enough storage space on my disk, but I may want to remove things from time to time because I really lose the overview. Either there are many dead bodies scattered in my file system, or I really get lost in an ever-growing system. And in this whole mess, the identifier, the folder name, is the only clue and information about my projects. Identifiers that often become detached from the project titles and content. It then becomes really hard to identify the project at all and recall its content and state. And then there is a problem with the history of all but trivial projects and the fact that the file system has no concept of time. Each project is in its present state, and all previous states are lost. Unless I make copies or clones and cause new trouble. Suppose it is Tuesday and my travel guide project is in a pretty good state. And then I have an idea. After each section, I'd like to add a photo and description of a typical national dish. I do some research and spend a couple of hours to make these changes. And on Friday, my new version is ready. But after showing it to friends, I realize that these new additions take up too much space and are only distracting from the real and important content. What now? The original Tuesday version is lost. To more or less restore it, I have to work through the text and remove all changes. But going back in time, I could have made a backup of my project on Tuesday, when I had my idea. That way I could always go back to this older state. But every backup increases the number of stored projects again. And if I make this a regular habit in my workflow, I need to start some extra bookkeeping to keep track of all these backups and versions. A variation of this backup would be a clone or branch of the project next to the original project. That way I can always compare different states. But each of these strategies solve a problem and cause new ones. And they all increase the complexity of my already complex system. For some challenges of digital project management, solutions do exist already. There are more and more tools that support some kind of project concept. The example shown is the OpenShot video editor that allows to create, open, save and close video projects. But such a project concept is very close to the medium and tool at hand. And there are the so-called version control systems, tools that do have a more general project concept and that keep track of project history and support a conflict-free development of different branches or versions. These systems have become indispensable for many software developers. And in this area, Git has become a real standard. And here's what happens if a project is maintained by Git. Git creates a so-called repository, hidden in a folder called .git, in the project's home directory, next to the so-called working file tree. And then on a Tuesday, when this working tree is in a good shape, I call for a so-called commit, Git's name for a backup of the project state that goes hidden in the repository and that further does not pollute the file system, at least not the visible part. And Git is really smart under the hood. It does not simply make a file tree copy when it makes a commit. Instead, it has a really sophisticated storage system which is irredundant. Suppose you make 4 commits in a row. You then have 4 backups in the repository, obviously. But the storage size that it takes in the repository for these commits is not 4 times the size of the single commit. It is only the size of 1 commit. When a commit is made, Git checks for every file and every directory, if it already is stored in the repository. And if the answer is yes, then it is not stored again. So if we make 4 times the same commit, the last 3 commits do not take new storage space. If they only differ in a little, they only take a little new storage space. There is no redundancy, no double savings. As a consequence, there is no trade-off between backup safety and blowing up the disk space. That is really cool. Git is also really powerful in the sense that the project history is not simply a stack of commits, but that history can develop in alternative branches. And each branch can become the working and development branch at any time by checking out and thus swapping the different versions again. But here's where Git also becomes really cumbersome, because the power is achieved with an increased complexity of its concepts and the restriction of only one visible file tree at a time. This enforces a whole branching system to rely on a complicated algebra with abstract commands. This complexity is not a necessary price to pay, as we will see. And yes, that also makes Git essentially the command line application that it is. Not that there are no GUIs for Git. They just can keep up with the required range of Git commands. So as much as Git has become a standard for programmers, its power and usability may never really come to all the other professional content producers that are not that used to the command line. The Caretaker in a project house is not only a version control system, which is equally powerful than Git, it is a digital management system in a much broader sense. It does not take files and folders, but projects as a basic entities and thus becomes a kind of higher order operating system for digital project management. It is not designed for the maintenance of one project, but for any number of projects. And it turns out that this makes even the management of one project much simpler and easier. Now, some projects can be used and reused in other projects. There is no need for a complicated algebra of branches. To enter a new branch for a project, just duplicate it and you can develop them both independently. Recall the problem with our example project right from the creation. A project has a title, which is its name for humans, and an identifier, which is the name of its home folder in the file system. A project in a project house does not suffer from any of the problems that are caused by this dichotomy. Such a project is by design made of 3 independent ingredients: a description, a project tree, when the project is active, and any number of backups. A project description is a small record, a JSON object by the way, and one of its values, the one in red, is a PID, the project identifier. It is always made of 40 hexadecimal characters, and it is automatically created when the project itself is created. And one remarkable property of this PID is that it is pretty sure that no 2 projects in the past and future history of the world will ever have the same PID. So this really qualifies it to be called a project identifier. And this is how our naming problem is solved. The green title can be changed at any time because it is only a value in the project description. And the project identifier is this strange enough value that will never have to be changed because it remains unique and has no connotations whatsoever. By the way, you will never have to learn or memorize these PIDs because the first 2, 3 or 4 characters will always suffice to distinguish and find the project. The Caretaker abbreviates PIDs to their first 4 digits, followed by 2 dots. It always mentions projects in their abbreviated red PID, followed by the green title, as is here done in the headline. Not only the naming conflict is solved for every project, but also the question of its location and movement. My projects are not scattered throughout the file system anymore. They are kept in the archive, hidden in the basement, and presented by the Caretaker in my browser. This introduction of two virtual rooms, archive and workshop, is not only an idealized picture. The project house, as it exists under its root in the file system, does have a hidden folder named .basement that holds a storage system similar to the irredundant storage system in the hidden .git folder of a Git repository. There are no projects anymore anywhere else in the file system, neither dead nor alive. And the virtual workshop is the other part on the project house root that holds the file trees of all active projects. If a project is alive and modifiable in the file system at all, then it is here in the workshop in its home folder named after its PID. In this picture there are 3 active projects. And this is a picture of the same workshop presented in the browser. And at any time I can make a backup of any of these 3 projects, which puts a snapshot of the active file tree in the archive. And I can close it, which removes the project from the workshop again. But the project is kept in the archive and can be activated again at any time with a simple push of the Activate button. This whole design has a version control system built in, one that is simpler and way easier than Git. If you have an active project and you like to create a new branch without losing the current one, simply create a duplicate. That will automatically create an equal project under new PID. And since all projects are always at the same place in the file system, namely in the workshop, all links out of the old project will still work out of the new project. And there is no complicated algebra of commands to let the 2 projects interact and merge. We can simply compare and interact with their file trees in the workshop. This is in a nutshell how things are done in our project house, maintained by our friendly Caretaker. There's a handbook and a whole series of video tutorials to explain all aspects of the Caretaker in the project house in more detail and depth. The homepage of all this can be found on the homepage of the TOFJS project, that is tofjs.org. There's also a forum dedicated to the Caretaker in the project house, hosted by Google Groups. Needless to say that all discussions are welcome.